All right, so let's get started with our study guide today. This is a marble problem that we've already done in class, and we've done a few of them in class. So it says a bag contains white marbles and blue marbles, and it's 79 in total. Total important. Total means that we're combining, adding everything together. Now, what are the things that we're adding together? We're adding together our white marbles and our blue marbles. And when we do that, what do we get in total? That's this number right here, 79 in total. So when we're doing these kind of problems, we do a big picture kind of scenario. And then we, on the right, we just label what we know and what we don't know. So we're doing white marbles and blue marbles. So when we do these type of problems, I told you in class to scan the problem and look for what you know absolutely nothing about. And if you read this problem, it says the number of white marbles is 6 less than 4 times the number of blue marbles. So we know something about the white marbles. We don't know anything about the blue marbles. And when we don't know the value of something, we use a variable. In this case, because we're dealing with blue marbles, I'm going to use the variable b. Right? What do we know about white marbles? Well, white marbles is 6 less than 4 times the number of blue marbles. So I'm going to circle less than, because less than we know is going to mean subtraction in reverse. So instead of 6 minus, it's going to be something minus 6. Now, what are we taking 6 from? Well, that's this part right here, and I'll do this in blue, since for some reason I underlined the whole problem. That's 4 times the number of blue marbles. So first it says 4 times. That's obviously going to mean multiplication. We're multiplying something times 4. What are we multiplying by 4? We're multiplying 4 by the number of blue marbles. Do we know the number of blue marbles? No. But we did already use a variable for that b. So that would be 4 times b, or 4b. Now, for white marbles, we're just going to plug in 4b minus 6. For blue marbles, we're just going to plug in b. And we are going to solve this equation. So if you remember in class, the steps that we went through is step number 1, step number 1, distribute if necessary. We don't have to distribute here. Step number 2, combine like terms, and we do have a couple like terms to combine. 4b plus b would be 5b. And then step number 3 is just to solve. We add 6 on both sides. We get 5b equals 85. And then we divide by 5 on both sides. And we get, that should be 17. So b equals 17. I'm sorry, I was about to move on, but this isn't our answer though, because this is, if we remember, b stood for the amount of blue marbles that we have, but they're asking for the amount of white marbles. So the easiest way to do this is, hey, if there's 79 in total, and there are 17 blue marbles, that means 79 minus 17 would give you your white marbles, which if you do that, you get 62. Right, 62 would be about the amount of white marbles that there are. The tree problem, we also did this problem in class. So first of all, remember what I told you in class. This is feet right here, and this is inches. We want to change them both to inches. So how would we change feet to inches? We would multiply by 12. So this wouldn't be 6 feet. It would be, if we multiply 6 times 12, it would be 72 inches. Right? And this wouldn't be 2 feet. If we multiply 2 times 12, it would be 24 inches. All right, now we can go ahead and read this and solve this. So it says algebraically determine exactly how many years it will take for these trees to be the same height. Same we know is going to mean equal. And what do we want to be equal? Well, it says right here we want these trees to be equal. Trees. What trees are we talking about? We're talking about tree type A, tree type B. That's what we want to be equal. What do we know about tree type A? Well, it says tree type A is 72 inches, right? And then it grows an additional 12 inches per year. Remember, per means multiplication. It's one of your rate words. So it's 72, then an additional, that's plus 12 inches per year, right? So that would just be 12 times, we don't know how many years, so it would just be 12y. What do we know about B? Well, we know that it's 24 inches, right? 24 inches off the bat. But we know that it grows an additional, so it would be plus. I don't want you to confuse this with a negative sign. That's not a negative sign. So it would be plus, well, it grows 24 inches per year. So it would be 24 per means times and we don't know how many years, so it would be 24y. Now we could go ahead and plug this stuff in. 72 plus 12y equals 24 plus 24y, and we could solve it. So distribute if necessary. We don't have to distribute. Second step would be to combine like terms. There are no like terms to combine. Third step would be to get your variables on the same side, and that we can do. So let's go ahead and subtract 12y on both sides. And if we do that, we get 72 equals 24 plus 12y. And then, well, what's your next step? Well, we just solved this problem, right? So our first step would be to subtract 24 on both sides. And I'm running out of space. So if we subtract 24 on both sides, we get 48. I'm running out of space. I'm going to put it over here. 48 equals 12y. And our last step would be to divide by 12. And if we do that, we end up with y equals 4. After 4 years, these trees will be the same height. All right, next, write an equation for each description. So we're not asked to solve it, just write an equation. It says the sum, okay, so sum we know is going to mean addition, right, of 14 and a number is we know is going to mean equals, an equal sign, 17. So is means equal, it's going to be equal to 17, and it's the sum, which means we're going to add, what are we adding? 14 and a number. We don't know the number, so we use a variable. 10, I'm not even going to try to say that name, T, wants to raise $175 for a school fundraiser. So in total, she wants to raise $175, right? So looking at the context of this problem, that means it's going to be equal to 175 because that's her goal. She wants to raise that much money in total. According to this, she has already raised $120, and we are trying to figure out how much more she needs to raise. So she wants to raise in total 175. So we know we're going to be adding 120 plus, well, the amount that she needs left, right? So we don't know how much she needs left, so we would just put an X or something like that. And that's it. Hector is visiting a cousin who lives 350 miles away. He has already driven 90 miles. How many more miles does he need to drive in order to reach his cousin's home? All right. So write and solve an equation with this. So we know he needs to go 350 miles in total, right? So 350 miles in total is the amount of miles he needs to drive. He's already driven 90 miles, and we know that in total means we're combining a couple things. So if we add 90 by how many miles he needs left, how many miles he has left to drive, we should get 350. Do we know how many miles he has left to drive? No, so we would use a variable. You could use any variable. I will use the variable D. That's it, 90 plus D equals 350. And again, you don't need to solve it, although I'm sure you know how to solve this. All right, next, in one baseball season, Peter hit twice the difference of the number of home runs Alice hit in 6. Altogether, they hit 18 home runs. Altogether means we're combining all of their home runs. So combining all together, that's going to mean addition. And when we add everything together, we get 18, right? That's going to mean equals 18. What equals to 18? Well, altogether, they hit 18 home runs. Who are we talking about in this problem? We're talking about Peter's home runs, and we're talking about Alice's home runs. So Peter's home runs plus Alice's home runs has to equal 18. All right, so let's talk about Peter. Let's talk about Alice. Remember, first we're going to look for the person that we know absolutely nothing about, which if you read this problem, we know something about Peter, but we don't know anything about Alice. So I'm going to use A for Alice. What do we know about Peter? Peter hit twice the difference. Now, this is going to be one of your parenthesis words, right? We're multiplying the entire difference by 2. Okay? We're multiplying the entire difference by 2. And difference, remember, means subtraction. Now, what are we subtracting? It says the difference of the number of home runs Alice hit. Well, how many home runs did Alice hit? A. And 6. All right? And that's it. Now we just go ahead and plug this in. So for Peter, we have 2 times A minus 6. For Alice, it's just A. And once we have all that information there, we just solve this. So our first step is going to be to distribute. So this would be 2A minus 12 plus A equals 18. Combine like terms. So we have 3A minus 12 equals 18. Add 12 on both sides. We have 3A equals 30. And then I'm running out of space again, but we divide by 3 and we get A equals 10. That's how many home runs Alice hit, but it's telling us to find how many home runs each player hit. So if we're looking for Peter, we could either plug 10 into this expression, or we could just think, well, if altogether the 8 hit 18 and Alice hit 10, that means Peter had hit 18 minus 10, which is 8. 1 month, Ruby worked 6 hours more than Isaac, and Svetlana worked 4 times as many hours as Ruby. Together, they worked 126 hours. So combining all of their hours together, they worked 126 hours, right? So that's going to mean all of their hours equals 126. Well, who are they? They are Ruby plus Isaac plus Svetlana. When we add all their hours together, we get 126. So look for the one that we know absolutely nothing about. We know something about Ruby. Ruby worked 6 more hours than Isaac. We know something about Svetlana. Svetlana worked 4 times as many hours as Ruby. We know nothing about Isaac, so I'll go ahead and put, since we're talking about, I don't want to use I, we'll just use X for Isaac, right? Now what do we know about Ruby? Ruby worked 6 hours more than Isaac. What does more mean? Plus. And it's going to be 6 plus Isaac's hours. We don't know how many hours Isaac worked, but we are using the variable X to represent Isaac. So that would be 6 plus X. Svetlana worked 4 times as many hours as Ruby. So times means multiplication. So we're multiplying 4 times Ruby's hours. What are Ruby's hours? We just figured that out. It's 6 plus X, right? So we're multiplying it by 6 times X. We put all this information in our equation. So for Ruby, we have 6 plus X. For Isaac, it's just X. And for Svetlana, we have 4 times 6 plus X. And we solve. So your first step is going to be to to distribute. So we distribute this 4 to each of the terms on the inside here, and we get 6 plus X plus X plus 24 plus 4X equals 126. Our next step is to combine like terms, and we do have a few like terms here. So X plus X is 2X, and then plus another 4X, right? That would be 6X. So it would be 6X. All right, and then 6 plus 24 is 30. 6X plus 30 equals 126. Then we solve this. So our first step is going to be to subtract by 30. And I ran out of space, so I'll write this information right up here. We'd be left with 6X equals 96. And then we divide by 6. And we get X equals 16, I believe. But X stands for Isaac, right? If we wanted to find out how many hours Ruby worked and Svetlana worked, then we'd have to plug in 16 for X. So for Ruby, remember Ruby worked 6 plus X, right? So because we know X is 16, it would be 6 plus 16, which is 22. 22. All right, so Svetlana, we know, worked it's 4 times as much as Ruby, and we just figured out Ruby worked 22 hours, so it would be 4 times 22, which is 88. All right. Community gym charges $50 membership fee and a $55 monthly fee. Workout gym charges a $200 membership fee and a $45 monthly fee. After how many months will the total amount of money paid to both gyms be the same? And what will that amount be? So the same is going to mean equal. And what do we want to be equal? We want community gym to be equal to workout gym, right? Right? Because it says after how many months will the total amount of money paid by both gyms, and those are the gyms that we're talking about, be the same. So what do we know about community gym? We know the community gym charges a flat $50 membership fee, no matter what. So that's going to be 50. And an additional, I'm running out of space here, let me move a little bit. And an additional, what? $55 monthly fee, right? So that's per month. Per means multiplication. So $55 per month. We're multiplying it by the amount of months that we go to that gym. What do we know about workout gym? Workout gym charges a flat fee of $200 and then an additional $45 monthly fee. So that's $45 per month, right? So that's 45M. With me so far? So now we just plug this in. So community gym is going to be 50 plus 55M, right? Workout gym is going to be 200 plus 45M, right? And we solve this. Let me go ahead and erase some stuff. Nothing to distribute here. Nothing, no like terms to combine. So we're going to move the variables to the same side, right? So subtract 45M on both sides. And if we do that, we are left with 50 plus 10M equals 200. And then we subtract by 50 on both sides, right? And we are left with 10M equals 150. Then we divide by 10. And we get our answer, which is M is equal to 15. After 15 months, both gyms would have the same cost. So these are just solving these inequalities here. So first up, you're going to want to distribute, right? So distribute here and distribute here. So 1/2 times 4x would be 2x, and 1/2 times a negative 2 would be a negative 1. Then negative 2/3 times 6x would be negative 4, and negative 2/3 times positive 9 would be negative 6, and that is less than or equal to 4. Then we combine like terms. I'm sorry, this was supposed to be a 4x. Let me change that. There we go. Then we combine like terms. So we have 2x and 4x, and then we have negative 1 and negative 6. 2x minus 4x would be negative 2x. Negative 1 minus 6 would be negative 7, and that's going to be less than or equal to 4. All right. Now, piece of cake, we just add by 7 on both sides. We get negative 2x is less than or equal to 11, and then we divide by negative 2, and because we're dividing by negative 2, we have to flip the inequality symbol, so that would be x is greater than or equal to negative 11 halves, and that's it. We could just leave it like that. And then this problem, again, we distribute first, right? And that's a negative 5 that we're distributing, so it would be x plus 1 is greater than negative 35, and then it's negative 5 times negative 2x, so that would be a positive 10x. Nothing to distribute here. No like terms to combine, so I'm just going to go ahead and move the variables to the same side by subtracting by 10x on both sides. If I do that, I get negative 9x plus 1 is greater than negative 35. And then if I subtract my 1 on both sides, I get negative 9x is greater than negative 36. And I'm dividing by a negative 9, so I must flip the inequality symbol. That would mean x is less than 4. Positive 4. Negative and a negative would be a positive. Last page. Okay, so it says Dave has $15 to spend, right? $15 to spend. He can't spend over $15. So right away I'm thinking of a specific inequality symbol that I'm going to use, but let's keep reading. So he has $15 to spend on an $8 book, and, which usually means addition, right? And 2 birthday cards, which we don't know the cost of it, and they told us to use a variable C for his friend. How much money can he spend on each card if he buys the same card for each friend? So $15 to spend, that means he could spend exactly 15. He can't spend more than 15, so it's going to be $15 or less. That right there tells me that our inequality symbol is going to be less than or equal to, and that has to be 15. Now what is he buying? He's buying an $8 book, right? That's it. And 2 birthday cards, right? 2 birthday cards, so it would be 2 times C, because we don't know how much birthday cards cost yet. All right? And that's it. That would be your inequality. Now you have to solve these two. So how would you solve it? You'd subtract by 8 on both sides, right? And you'd be left with 2C is less than or equal to 7, right? And then you would divide both sides by 2. And here we would not want to leave it as a fraction, right? So you'll have calculators if you need it, or this one's pretty easy to divide without a calculator, but we'd have to change it to a decimal because we're dealing with money here, and that would be 3.5 or $3.50 is the most that he could spend on each card. 6 more than 5 times the number is at least 21. Well, at least we know is going to mean greater than or equal to, right? And it's at least 21. And that's something that you should know. You should know that at least is always going to mean greater than or equal to. Now, what's going to be greater than or equal to 21? It says 6 more than. Well, more than means addition, right? So we're adding 6 with something. What are we adding 6 with? 5 times a number. 5 times means multiplication, a number. Do we know the number? No, but they give us the variable they want us to use, which is x. So 5 times x. And that's it. And you just solve. We subtract 6 on both sides. We are left with 5x greater than or equal to 15. And then we divide by 5 on both sides. And we be left with x is greater than or equal to 3. And last one, Tony can carry up to 18 pounds in her backpack. Her lunch weighs 1 pound, her gym clothes weigh 2 pounds, and her books B weigh 3 pounds each. How many books can she carry in her backpack? Okay, so we know that her backpack can carry up to 18 pounds. So it can carry 18 pounds, it can't carry 19 pounds, right? Anything up to 18 pounds, that means it's going to be less than or equal to. Right? So right here it says up to 18 pounds, less than or equal to. So what does she already have? She has her lunch, which weighs 1 pound. So we're going to put that 1 pound. Plus, she has her gym clothes, which weigh 2 pounds. 2. And now she's trying to figure out how many books she could carry, right? We know that each book is 3. Each usually means multiplication, right? We know that each book weighs 3 pounds, and she's trying to figure out how many books she could carry. So it'd be 3 pounds each times the amount of books. And that right there will tell us how many books she'd be able to carry. And we would just solve this. We combine like terms, which would just be 1 plus 2, which is 3. We'd subtract 3 on both sides, which would be 3b is less than or equal to 15. And then we divide by 3 on both sides, and that would give you your answer, which means she could carry at most, she could carry up to 5 books. That's it. She can't carry any more than 5 books. All right, so I hope that helped you out at least a little bit. If not, come to tutoring tomorrow. That's your study guide. If you need to rewatch this video, please do so. Tomorrow's your test. Make sure you also complete all your Delta Math and other assignments before tomorrow. I will see you tomorrow.